Have you ever looked up at the night sky and thought, wow, space is huge, but what's really out there? Here's the wild part. Everything we can see, stars, planets, galaxies, makes up only about 5% of the universe. Just 5%. The rest, that's where the mystery begins. Around 27% of the universe is made of something we can't see or touch. Scientists call it dark matter. And no, it's not dark like a shadow. It's invisible. It doesn't give off light, and it doesn't reflect it either. But we know it's there because of the way it pulls on galaxies and stars with its gravity. Think about it. If the universe is a giant puzzle, then most of the pieces are hidden. We only see a thin slice of reality, and that's both terrifying and exciting at the same time. So here's the big question. What exactly is dark matter, and how do we even know it's there if we can't see it? If we can't see it, how do scientists even know dark matter is real? The answer is simple: gravity. Back in the 1930s, an astronomer named Fritz Zwicky was looking at galaxy clusters. He noticed something strange. There wasn't enough visible matter to hold them together. By all logic, those galaxies should have drifted apart. But they didn't. Something invisible was keeping them bound, like glue. Later, in the 1970s, another astronomer, Vera Rubin, studied how stars move around galaxies. Normally, stars on the edge should orbit slower than the ones near the center, kind of like how planets move around the sun. But nope, stars on the outer edges were moving just as fast as the ones inside. That doesn't make sense, unless there's a huge amount of hidden mass spread out across the galaxy. So, scientists started calling this missing stuff dark matter. Even though we can't see it, its gravitational pull is impossible to ignore. It's like an invisible hand shaping the universe. Picture this. Light from a faraway galaxy is traveling through space toward us. But if there's a massive object in the way, the light bends. Kind of like how things look distorted when you look through a glass of water. This is called gravitational lensing. Einstein predicted it back in 1915, and years later, telescopes proved he was right. The bigger the mass, the more it bends the light. Now here's the twist. Sometimes, the amount of bending we see is way more than the visible matter can explain. That means there's extra hidden mass causing it. And yep, you guessed it, that's dark matter. Astronomers check this by looking at galaxy clusters. Behind them, distant galaxies look stretched, bent, or even like glowing rings. But when they calculate the mass of the stars and gas we can actually see, it's not enough. Something invisible must be adding more gravity. So the big surprise is this. The hidden matter in the universe is way more than the stuff we can see. The stars, planets, and galaxies we love looking at are just the tip of the iceberg. The real bulk of the universe is hiding underneath dark matter. And that leaves us with a huge question. If this invisible giant shapes the universe, what else is it capable of? Have you ever wondered how galaxies formed? Billions of stars, gas, and dust all coming together to make giant spinning disks. But here's the catch. Without dark matter, galaxies as we know them wouldn't even exist. Why? Because normal matter alone doesn't have enough gravity to pull everything together. Before the first stars lit up, matter was just floating around. But there was already an invisible skeleton in place, a cosmic web made of dark matter. Scientists describe it like this. Imagine a giant spider web stretched across the universe. Dark matter forms the thick strands, and visible matter, stars and galaxies, stick to those strands like tiny drops of dew. Computer simulations make this crystal clear. Take away dark matter and galaxies fall apart. Leave it in and galaxies line up in long chains and clusters, just like we see in the real universe. Dark matter doesn't just help galaxies form, it keeps them alive. As galaxies spin, their stars should be flying off into space. But dark matter acts like invisible glue, holding everything in place. Think about it. The Milky Way, our home, has been spinning for billions of years without flying apart. Without dark matter, the sun might have been flung out into empty space long ago. In a way, all of us are living under the quiet protection of dark matter. So here's the big question. If dark matter is the true architect of the universe, why can't we see it yet? You might be asking yourself, if dark matter is so important, why can't we see it? Well, that's the fascinating part. Dark matter doesn't interact with light at all. It doesn't reflect it, it doesn't emit it, and it doesn't absorb it. Our eyes, and even our most powerful telescopes, work by detecting light. So to us, dark matter is completely invisible. In other words, dark matter is like a ghost drifting through the universe. It's everywhere, but you can't touch it or catch it directly. So how do scientists know it's real? Because dark matter still has mass, and mass means gravity. Even though we can't see it, we can measure its pull on galaxies. It's like the wind. You can't see the wind itself, but you know it's there when you watch the trees swaying. One of the clearest examples is gravitational lensing. Massive objects in space bend light passing by them. When scientists see strange warps or stretched out shapes in the light from distant galaxies, it means there's a hidden mass in the way. That invisible mass? Dark matter. But here's the twist. Dark matter isn't just invisible, it's silent. It doesn't interact with atoms, electricity, or magnetism. Gravity is its only way of revealing itself. And get this, dark matter makes up about 85% of all matter in the universe. It's right in front of us, yet we can't pin it down. It's like being in a crowded room, knowing someone invisible is there because you hear faint footsteps. But no matter how hard you look, you never see them. Scientists have been chasing this mystery for decades. Huge detectors have been buried deep underground, waiting to catch even the tiniest trace of a dark matter particle. So far, nothing conclusive. But the hunt goes on. And that brings up a mind-blowing possibility. What if dark matter doesn't even exist? What if we've been misunderstanding how the universe really works all along? To figure out dark matter, scientists are basically acting like detectives. There's this suspect that's invisible, untouchable, but constantly leaving behind clues. So how do you catch something like that? The first method, underground detectors. Deep inside the Earth, scientists build massive tanks filled with ultra-pure liquids or crystals. They wait, hoping that maybe, just maybe, one dark matter particle will bump into something inside and leave a trace. One of the most famous of these experiments is in Italy, at the Gran Sasso laboratory, buried a mile underground. The second method, space telescopes. NASA and ESA telescopes scan the skies, measuring how galaxies move and how their mass is distributed. And what they see is shocking. Galaxies spin way too fast to be held together by visible matter alone. Something unseen is adding extra gravity. That's dark matter's fingerprint. The third method, particle accelerators. The most famous one is the Large Hadron Collider at CERN. Scientists smash protons together at nearly the speed of light, hoping to create or detect new particles that could finally reveal dark matter. So far, no direct evidence, but the search continues. Why go through all this trouble? Because understanding dark matter isn't just about astronomy. It's about answering one of the biggest questions in all of science. What is the universe actually made of? And what are we made of? Think about it. Everything we build, every phone, satellite, or rocket, is made of ordinary matter. But that's just a tiny fraction of the cosmos. The rest is this invisible stuff we don't understand yet. If we can detect dark matter, we might uncover brand new laws of nature. And who knows? It could change physics forever. That's why billions of dollars are being spent, and why generations of scientists are dedicating their lives to chasing this ghost. Because the answer might unlock the deepest secrets of the universe itself. Picture a galaxy. Billions of stars, giant clouds of gas and dust, all spinning together in space. But here's the strange part. If we only count the stuff we can see, these galaxies should have torn apart a long time ago. Let me explain. Imagine spinning a toy pinwheel really fast. The blades fly outward, right? Same thing with stars. Galaxies spin like enormous pinwheels, but if visible matter was the only source of gravity, those outer stars would have been flung into space ages ago. So what's keeping them in place? Dark matter. It surrounds galaxies like an invisible weight, holding everything together. Astronomers call this the galaxy rotation curve. Back in the 1970s, Vera Rubin, a pioneering astronomer, measured how galaxies spin and found this weird pattern. Her work became one of the strongest proofs that dark matter is real. Take our own Milky Way, for example. It's about 100,000 light-years across and has over 200 billion stars. But here's the kicker. All those stars and gas clouds we see only make up a small fraction of the galaxy's mass. The rest, a massive halo of dark matter we can't see. Think about it. We're just a tiny speck in the middle of this huge galaxy, floating inside an invisible ocean of dark matter. Without it, the Milky Way's stars would scatter into deep space. Our sun, and us along with it, wouldn't even be here. Dark matter isn't just holding galaxies together. Simulations show that it actually builds them. Galaxies form and grow along the invisible skeleton of dark matter, like beads on a hidden cosmic string. Without it, the universe wouldn't have the grand structure we see today. So the big question is, are we really the main characters of the universe? Or just extras on a stage built by something we still can't see? Dark matter is one of the biggest puzzles in the universe. We've got plenty of clues, but still no clear answers. Scientists aren't giving up, though. Deep underground, they've built giant detectors, hoping that one day a dark matter particle will leave even the tiniest trace. These particles barely interact with normal matter, like ghosts. In fact, billions of them might be passing through your body every second, and you don't feel a thing. Another approach is particle colliders, like the Large Hadron Collider at CERN. There, protons are smashed together at nearly the speed of light. The hope is that in the chaos, dark matter will reveal itself. If that happens, our entire understanding of physics could change overnight. But here's the catch. We still don't know what dark matter actually is. Is it made of unknown particles? Or are we misunderstanding how gravity itself works? What if the laws of physics are different from what we think? This mystery matters because dark matter isn't just about the cosmos. It's about us too. Remember, about 85% of the matter in the universe is dark matter. Everything we know, stars, planets, you, me, makes up only a tiny fraction. That means most of the universe is hidden from us. And yet, that's what makes the search so exciting. Who knows? Cracking the mystery of dark matter might not only tell us what the universe is made of, but also whether we're truly alone in it. It's almost as if the universe is whispering, "You haven't seen anything yet."